Hi, today we are in a beautiful San Francisco in the MemSQL office. Hi Eric, who are you and what do you do?
I'm the CEO and co-founder at MemSQL, and it's good to have you over.
Great, awesome. What is MemSQL?
MemSQL is a real-time database for transactions and analytics. It's core infrastructure, and it's designed basically to help businesses optimize their real-time operations.
How did you come up with such an idea?
So I worked at Facebook a few years ago, prior to starting MemSQL. And my co-founder and I were seeing sort of the tip of the spear of big data problems being solved at Facebook. And it really was an inspiration for us to depart and start our own company.
And what did you see working there at Facebook? And what things did you take of there and said, okay, now we would like to offer this to the world?
As you know, Facebook is one of the largest web destinations on the internet. And it was, at that point, it still is, scaling with a lot of infrastructure and systems designed to support 1 billion for people every month. So a lot of the big data problems internally were about volume, but there were also new challenges arising around real-time analytics. How do you actually change Facebook quickly so that you can adapt it to certain geographies or certain different user demographics? And what we saw was basically a lot of early work around real-time processing systems, not just the standard batch systems like data warehouses or Hadoop. So we realized that this would be very, very useful for a lot of the rest of the IT industry. So it was one of the reasons why we left, to bring it to everyone else.
Did you validate this idea that it's working for other companies as well before you left Facebook?
My background at Facebook was in working with some of Facebook's key partners. So I was a partner engineer, and I saw a lot of those partners basically, choke under the Facebook social graph. Just so much data was available. So you saw a lot of other companies obviously trying to consume that data, and they invariably had database problems, bottlenecks in the database tier. So it was both seeing what was happening internally at Facebook as well as some of our partners, where it was a lot of validation. And then, of course, you look at the broader industry at large, and data volume and velocity is always a problem. It's why it's called big data.
Yeah.
It's a big, big problem to be solved.
And walk me through the process. So once you've left Facebook with your co-founder, what did you do? Did you just right away build a new database, or did you first try to find funding, or did you first try to find customers?
So we were accepted into an accelerator program called Y Combinator, and that provided a great pathway for us to leave Facebook and basically get started in a 2-bedroom apartment in Menlo Park, 2 guys and a dog. We basically had given up our salaries or all the great perks for what was $20,000 in startup capital.
Yeah.
And to answer your question, Facebook is a very special place. It's a great place, but we also knew when we left that we would be working, from scratch on everything. And when you decide to build an enterprise company, especially one in database infrastructure, there's really no ability or expectation that you would start with something. You're starting from scratch. So the first step was obviously to begin fundraising to build a team that could deliver the software. And that's what we did. So we spent 2 months at Y Combinator and graduated the program and concluded with a $2 million seed round, which gave us the capital to build a team of engineers to really release the first MVP, minimal viable product in the system.
So you only first released the first database product from MemSQL after you got the 2 million, and engineers have been working on that.
Yeah, databases aren't easy. It took us about 2 years of stealth mode to deliver the first MVP. And that was basically, only a stepping stone for us, because actually the full product was not released until April of 2013. So it took a lot of effort to deliver the product, but now that we have it out in the market, out in the wild, it's been phenomenal to see all the customers using it. So building a database is not for the faint of heart, and it takes a lot of money, and you need basically good alignment between funding and team to deliver something like a database. Typically, though, for most startups, you want to have far shorter response times on your MVP. For application stack, you should be thinking in terms of weeks to months, not years.
Yeah. Did you do any startup before MemSQL?
It's my first startup.
Cool.
Yeah.
Let's talk about the business model of MemSQL. So what are the specific customer segments that you are targeting?
Sure. Well, at a high level, the business model is focused on delivering software to our customers via term-based subscription model. So it's basically a commercial software license that our customers subscribe to. And it gives them an ability to expand as they need. A lot of the industry in our space will price by core or by server. We price by capacity, which means that our customers are encouraged by us to use as much CPU as they want. So this means that they can get more performance out of the system, irrespective of the number of cores that they want to use. So they can always add more cores to the database.
I mean, there are so many different databases, like SQL databases, NoSQL databases, and one of those NoSQL databases is MemSQL.
We're very much SQL. We're not NoSQL. We're a relational database.
Oh, really?
Yes,
okay.
Of course. Yeah, it's in our name.
Okay.
Actually, it's a great thing to touch on because I think a good name is so critical when you want to be very prescriptive about what it does. So our name comes from the fact that Mem stands for memory, and SQL stands for structured query language. So it lets any developer know immediately what we do. And best of all, we paid $6 for the domain name. It was just available.
Awesome.
Yeah.
So what is the big difference then between normal SQL databases and MemSQL databases?
Like a normal relational database?
Yes. Yeah.
The biggest difference is that it's designed to be on a distributed system. So most disk-based databases are single box. Ours is a multi-box design. And then, of course, mem for memory means that most of the first operations are held in memory. And then, of course, we put them on disk for the customer. So the biggest difference is that we're very, very fast and we're analytically focused. So you can use the scalable architecture to basically compute faster.
Can you name us some kind of use cases that, for example, some customers did based on MemSQL?
Sure. So all of our customers use us effectively for optimization around their businesses. Within financial services, we do a lot of fraud detection, trading analysis, risk exposure analysis, ledger consolidation, a lot of things that are just around the concept of very fast processing. Within ad tech, we do real-time bidding and attribution for our customers, as well as real-time segmentation, basically the ability to segment your users based on certain profile characteristics. We have a very great expertise with IoT data, Internet of Things. So we track a lot of smart devices for our customers, from the likes of Comcast with Xfinity, Samsung with their smart TVs, and some other great customers that use us for various devices as well.
And walk me through the process, how it typically works. Is it like just an assumption that you build, for example, a Kafka Flume chain for the ingestion part, pump the data that you need for a specific use case into the MemSQL database, and then how do you get this out?
Yeah, that's a great question, especially because it lines up exactly with what we are doing with our latest product called Streamliner. So what you described around a chain with Kafka connecting to something transformation here like Spark, going to MemSQL is a new product that we launched last month called MemSQL Streamliner for Spark. What it effectively gives you is an ability to copy and paste the Kafka URL into the manager dashboard of MemSQL, subscribe to a topic, and then lo and behold, the data is already available for analysis in MemSQL. So we support semi-structured data with JSON, and that Kafka feed is basically piped into a JSON data type, a JSON column in a MemSQL table. At that point, you can use SQL to traverse it, analyze it, index it, join it, whatever you want. But that's a real-time use case that is extremely exciting because so many customers are actually getting onto the real-time data pipeline use case.
Okay, cool. I mean, for analytics, I totally get it that you are close to real time.
No, we're very much real time. So we can consume millions of events per second, and the way we design the system, an insert will never block a select, and a select will never block an insert. So this means that you can be inserting data and reading across it, scanning across billions of records at the same time. So there actually is no delay in the analytics. So you can get as close as you can down to the last transaction, down to the last click.
And what is the secret sauce or competitive advantage that keeps you ahead? For example, we met in another company, also in the database space, and they said, hey, we are the leaders currently in the database. That's why we have the biggest ecosystem.
Sure.
This is our competitive advantage. Huh?
Sure.
What's yours?
Well, at the end of the day, as a core technology company, our competitive advantage is the software that we build and how we've built it. Certainly, how we built the software is worth sharing a bit. I mean, it's very hard to build, so you file patents and then you give talks and we go to database conferences. But at a high level, we do something to how we store the data. So we use lock-free data structures in memory. If you're familiar with database data structures, a B tree is a typical data structure for a disk-based system that has no need in memory. So the analog for an in-memory system is a skip list. And that skip list lets us do very rapid scans. We have a lock-free hash table as well for those quick key value lookups. We also have a distributed query optimizer. So the fact that our query optimizer can take a query that a user might send to the system, will break it down into smaller pieces and then push it out to other machines for computation. How we actually do all this is obviously the core part of MemSQL. But on top of that, in our execution engine, we also actually will convert your SQL query into machine code. So this is an amazing improvement because you're no longer bottlenecking on I/O, and we are now optimizing as best as we can around CPU. So by removing interpretation from a hot code path, you can effectively squeeze the CPU for even greater performance. So it's a combination of a lot of different things, but we have an ability to work with data very quickly, in part because of what we designed in both the execution engine and the storage engines.
How do you acquire your customers? Are you having a direct sales force, or are you using some kind of distribution partners?
Sure. So in the early days, when you get started, you always have to be the chief sales officer as a founder. And that's what I did in the early days. Now we do have a field team, we do have direct sales teams, and an inside team. And typically, you want to work with customers that have a problem, and you can segment them in terms of who is going to be likely to be a customer. So there are certain industries that we don't sell to, something like insurance, which is a very slow-moving industry. But you have to know who your customers are, and then as soon as you do, you can start basically working with sales teams to acquire them. We have a community edition. We have a free version of the product that anyone can use for free forever. And that's been a great source for us to basically build our relationship with those customers.
And why are you not selling to the insurance companies? Only because the adoption rate is too slow? Or?
No. There are certain industries that are just don't have a need for fast computation.
Okay.
So insurance is a very well-architected or well-understood, I should say, industry. For example, there are what's something called actuarial tables that tell you pretty much accurately when someone's going to die, right? And then the whole business model of that industry is basically doing a very simple risk model around how to optimize that function. So those are certain industries that they are probably fine with batch analytic processing. Where we come into play with real time is around faster moving industries, things like financial services, ad technology, telecom, online business. Those are the sort of industries that really benefit from faster information processing.
What is your assessment of the trends in the database landscape? Where you see the relational and the not relational databases. What is your perspective on that?
Sure. I think there's been general recognition that NoSQL as a category will effectively dissolve into the larger category of databases in general. And I say that because most NoSQL vendors are actually effectively adding SQL back into their mix. But you also have relational vendors like MemSQL and Oracle and Postgres that are also adding a little bit of NoSQL into the mix. So I mentioned earlier that we have that JSON data type. That's an unstructured or semi-structured feature that our customers love to combine with relational algebra. So what Gartner is predicting is that NoSQL as its own category will cease to exist over the next few years because anything that of meaningful value will eventually have SQL, especially in analytics. You need to do a join in analytics. You need SQL for that calculation. So what we've seen in the market is a lot of the vendors add SQL backend somehow or some way. So over time, you're going to find that what is going to result is what's called a multi-model database. And a multi-model database is just a way of saying that a database has multiple means of interacting with data.
And is it really realistic to have a database who has really a multi-purpose? Because I've seen a lot of databases who are for a specific type of usage, like graph databases.
Yeah. There's always, I think, a specialist or specialty databases that are well-suited, like graph databases, for example. Certainly something like a document database can have good use cases sometimes. But generally, any data that's useful to a business will be structured at some point. So it's always just a matter of when that data is either deleted or structured.
And what is your opinion then on the Hadoop world, so to speak? Because there's also one way of how you can store data and batch it. Of course, it's the real time.
Well, it fills exactly into the need of two things around the relational or SQL question versus batch processing. So at a high level, Hadoop is great for storing data. I mean, HDFS is really what it's all about. And if the cost of storage is zero, and it is, then something like Hadoop should exist, and I'm glad it does. Of course, what you've seen in the Hadoop space is a general disconnect between the storage, which is HDFS, and the execution, which to date has been MapReduce. Now, MapReduce has been proven, everyone agrees, it's very, very obtuse, hard to work with, and that's why you're seeing a lot of innovation with SQL on Hadoop, like Impala or Presto coming up to play. And that's exactly, it fits the thesis, at least, or the hypothesis, that SQL is going to carry the day in the enterprise. And certainly even in the big data market, SQL is going to carry the day. So Hadoop is great for batch processing, but when you need real time, using something like in-memory is absolutely critical, which is why something like Apache Spark is very exciting, because it's adding an in-memory execution environment to the Hadoop ecosystem.
Eric, imagine your younger sister comes to you and says, "Hey, Eric, I would like to start a company." What advice would you give her?
At a high level, I would assume that, I will assume that, let's say she is a recent grad from college. So maybe she's just finished her degree in computer science, and she's thinking about doing a company. And the very first thing I would tell her would be, don't do it yet. I would say what you want to do is spend a couple of years at a minimum in an industry that you really care about and work at a big company so that you can understand how big companies work and basically absorb a key part of that industry or that vertical. Once you've basically been able to learn a lot about that space, then you can start thinking about joining or starting a company. But I feel that it's so in vogue to start a company in your dorm room. And you'll find that all of the most successful companies that do start that way are, by definition, anomalies. When Mark Zuckerberg started Facebook, he didn't intend to start Facebook. It was just a side project, a hobby. And he only left college because it had to be built into something bigger, and he was feeling the pressure to do that. So you really can't force it in your dorm room or even right after college. You really have to figure out an industry you care about and learn about it. And then you can start thinking about innovating there in your own sort of startup. My own career has the same path. I worked at enterprise companies, consumer companies, and at Facebook, another consumer company. And I was able to learn a lot in my few years working to say, I'm ready to start something like MemSQL.
Totally agree. I mean, you need to have some domain knowledge.
Right.
If it's like dating, maybe you don't need to work at some other company.
Right.
Maybe you just go to the discotheque.
Yes.
But if it's like you want to disrupt the insurance world, then maybe you should work in an insurance company.
And also, of course, young people are always sort of encouraged to be trained and learn, right? So it's always up to a company to provide that training. I would say probably the biggest benefit, though, of course, is that you get to learn how to be a manager. If you stay enough time, you'll eventually be able to learn how to manage people. And that's the hardest thing to do because you just can't read about that in a book. You have to practice it. And all the better if you can actually learn those techniques and learn how the core principles of management by working at a larger company that needs something like that. And then when you're ready to do it, then you can have a chance on your own.
What other advice would you give your sister?
So at a high level beyond that, let's just say that you fast forward a couple of years and maybe she doesn't want to start her own company, but she wants to join a startup. I would say that the easiest way to go about it is to do your research on all of the best companies backed by tier 1 venture capitalists and just piggyback on the hard work of those VCs to validate what are the good startups and what are the ones most likely to succeed. So just as there are tier 1 and tier 2 universities, there are certainly strata in VC, and you'll find that all of the most competitive companies are backed by the most competitive venture capitalists. And it's really great to join a Series A or Series B company when you're young because there's so much to do and you have a lot of freedom inside to basically work and contribute. So my advice, after a couple of years of work or whatever have you, would be say find a great company backed by a tier 1 venture capital firm that would benefit from someone with your skill set. It could be in computer science, it could be in marketing, it could be in sales, but you're going to learn a lot more in a early stage company at a Series A or Series B level than you would if you were to join a larger company at a DE, late stage company.
Sure. Great. Eric, thank you so much for your time.
Oh, my pleasure. Thanks for coming over.
Oh, sure. And next time, if you want to really start a company, think about it twice. Because if you don't know that there's a big problem that needs to be solved, maybe you should just start and work in a company like MemSQL or another Series A, Series B finance company. Thank you so much. Great.
Cool. Thank you.